Hello, and welcome to a special ANS event on what really happened at 3 Mile Island. I'm Craig Piercy. I'm the Executive Director and CEO of ANS, and I'll be serving as today's moderator. I'll be interviewing Lake Barrett, who led the NRC's cleanup efforts at 3 Mile Island. Before we begin, a few program notes. We'll be taking a few questions toward the end of today's program. Please use the Q&A function to submit them. We'll get to as many as we can in the time allotted. Note that the event is being recorded and a link to the video will be emailed to you later today. Certificates of attendance are available by request. Please see the chat for contact information. And finally, we ask that all participants adhere to the ANS Code of Ethics and Respectful Behavior Policy, which can be found at ans.org. Okay, let's get into it. Unit 2 of the 3 Mile Island nuclear power plant near Middletown, Pennsylvania, experienced a partial meltdown of its core on March 28, 1979. Though its small radioactive releases had no discernible effects on plant personnel or the public, it was the most serious accident in U.S. commercial operating history. The accident led to major reforms in the operation and regulation of U.S. nuclear plants, which helped make nuclear today one of the safest forms of energy available to humankind. Last month, Netflix released a 4-part docudrama entitled Meltdown, 3 Mile Island. In it, the showrunners blend a mix of honestly great archival footage of the event and its aftermath into a dark narrative of risky cleanup maneuvers that put the, quote, survival of the East Coast in the balance. In May 2022, the show spent 1 week on the top of US Netflix top 10 list, 2 weeks on the Canada top 10, and 1 each for Slovakia and New Zealand before the ratings fell off. Yet, in our algorithm-driven world, one that increasingly blurs the distinction between journalism and entertainment, shows like The Meltdown live on in the Netflix recommendation engine and can exert a hidden pull on our collective perception of history. That's why we at ANS thought it was important to ensure that the historical record is there for anyone looking to answer the question, what really happened at TMI? Now I'd like to introduce our guest, Lake Barrett. Lake is an independent consultant in the energy field, serving both government and commercial capacities in the nuclear energy and nuclear materials management areas for over 5 decades. He currently supports the recovery of the Fukushima nuclear reactor accident as a senior advisor to the Japanese government and the Tokyo Electric Power Company. At the Nuclear Regulatory Commission, he served at multiple senior technical and executive positions, including his time as the on-site director and senior federal official for the cleanup of the 3 Mile Island reactor accident. For additional information on Lake, please see below or on the chat. And so with that, Lake, welcome. Thank you for joining us. Glad you're here.
Thank you, Craig. Pleasure to be here.
So let's start at the beginning. How did Lake Barrett get into nuclear?
Well, I graduated with a BS degree in mechanical engineering from University of Connecticut in 1967. My father had recently died and my mother was a widow, so I needed to stay close to home. So I went to work at Electric Boat Division of General Dynamics in Groton, Connecticut, and worked as first a S5W reactor test engineer training, and then in design and construction operation. I served as a radiological engineer for the last refueling of the USS Nautilus, also as a decommissioning engineer for the US Triton, our only 2 reactor. So I got a lot of experience there at Electric Boat. As an Admiral Rickover contractor, I was extremely indoctrinated in the Admiral Rickover nuclear culture management world, which came to serve me very well later on in life.
So now, on the day of the accident, you obviously weren't there. Tell me a little bit about what you were doing in those first days when you were with the NRC.
Okay, I was with the NRC in the Division of Operating Reactors in Bethesda, Maryland on that day. We'd heard that morning at about 10 a.m. That there had been a declared emergency at 3 Mile Island. The NRC Emergency Operations Center was activated in another adjacent building. And I reported there with many other people, but there was a complete lack of information other than it was declared. It was said there were high radiation levels in the containment building. We asked why was that? And the answer was that there was a transient due to the trip of the reactor, and that cobalt-60 might be, in the primary coolant system. But the numbers were too high, and we were very skeptical and wanted more information, but there was no more information to be obtained from the control room because the operators themselves at that time were confused as to exactly, what had happened.
Mm-hmm. So now there's been some discussion about whether or not there was actually a hydrogen explosion that occurred on that first day. And Dan, I think we may have some pictures that we can put up that show some of the things that happened inside the reactor. So I think we want to go on beyond that, and then beyond that one. So Lake, talk us through some of these pictures. Was there an explosion?
No, there was not a detonation or an explosion of the hydrogen, in the containment. What happened was, as the core was damaged, and we always said the core was severely damaged for the first several years, because we didn't know if there was actually any melting of the core or not. Melting is a very difficult word insofar as, is it a Jane Fonda meltdown, or is it just the physical, melting of the fuel inside the reactor vessel? But anyway, what happened was a lot of hydrogen was released into the containment building. Around 1 p.m. on the 28th, there was a deflagration, a burning of it. Now, basically, it's something like if you turn your gas grill on and don't put a match in or a lighter in right away, and then you do it a little bit later, you get a big woof, and a flame front goes through. When we got into the containment building a year later, we could see evidence of what happened. As you can see in this picture here, you can see the pressure spike of around 2 atmospheres, did collapse the drum. The pressure wave threw a steel door open and bent the door. Some of the other pictures, please, Dan, you had passed. There was a melted phone, you can see from the radiation, but there was no shock wave. There was no explosion per se, because the phone still was sitting on the edge of the table. One of the other ones you can see, this is inside one of the cabinets. You can see on the right-hand side, the paint was peeled off the cover of the metal cabinet, but inside were plastics that were untouched. And the one before that, you can see plastic that was wrapping on wooden scaffolding that was charred, but the scaffolding was not moved anywhere. So there was no explosion inside. There was a rapid burn.
So you were at TMI twice, right? Once immediately after the events of March 28th, and then obviously a longer term of duty as the senior NRC official on site. Maybe talk about both of those. What did you do immediately after, and then we can get into that longer tenure during the cleanup.
Okay, well, initially, the first days, I was in Bethesda for the first week, and that evolved into the chaotic times of the lack of communication from the control room. Information kind of slowly drifted into us. It was, early Thursday, we started to realize that there was significant core damage, was confirmed when the sample was taken. It was very highly radioactive. So we knew there was severe core damage. Melting, we didn't know for sure yet, but it didn't really matter because we knew the core had probably collapsed. And we also learned about the pressure excursion, the burn inside the containment building. So we knew we had a severe situation. And we started getting into mitigation efforts to support how to mitigate this and also to try to improve the communications. but it was very difficult to extract information out of the site because we didn't know. They didn't know themselves. I don't believe there was any intentional withholding of the information by any of the people who were there. There were NRC people in the control room along with the GPU med ed people at the time. But we were gathering the information. Then there was known as Black Friday when we had the evacuation situation. We were looking at the situation of degassing the primary coolant system, which was heavy in hydrogen. We were filling through the waste gas compressors, the tanks, and did some advanced calculations about potentially, how significant that might be from a public health and safety point of view. We'd done some quick calculations based on the first sampling, and we thought if the relief valves had lifted in those tanks, there would be about a 1,200 MR per hour at the site boundary. I was in the process of briefing the executive committee at Harold Denton, Vic Stello, and the senior people at that time, Friday morning. And then a report came in from the site that there was 1,200 millirem per hour reading. Now, it was assumed by us erroneously that was a site boundary reading where it was a helicopter hovering over the exhaust vent. But that kicked in a dialogue by the senior folks there about what should be done. And there was just so much frustration due to the lack of information that we had from the site. So ended up with the governor having a precautionary evacuation, basically due to the uncertainty that we had. But reality was, on Wednesday night, when the main coolant pump was restarted, the plant was thermodynamically stable, at that point. But we were degassing down through the letdown system, and there was iodine in the air in the auxiliary building, very high radiation levels due to the the fission products that were in the letdown primary coolant system. So that continued on that week, and then we sort of had a shift turnover, and then I went the following week. I was to relieve the first set of NRC people with Harold Denton at the site. So I spent 3 weeks at the site, basically mitigating iodine that was being released from the auxiliary building, very low levels, but nonetheless measures, we could measure it. So it was changing the charcoal in the filters and that sort of thing is what we were doing. And Ben Rushi was my boss there, at that time.
So, and just really quickly, so you were measuring 1,200 millirem, and that does get referenced in the series, but that was from the exhaust stack. That was not at the boundary. That was in the plant itself. So you can reasonably assume that those the elevated readings that occurred around the plant kind of came from that concentrated source.
Basically it was the exhaust valve out of the stack at that point, but they were relatively low. That was a spike of noble gases. That was a noble gas, xenon 133 primarily at that time, which has very low biological significance and decays away very rapidly. So although the gamma level was fairly high, but it was a local right over, it was not at the site boundary. The maximum site boundary doses, for the entire period, if people had even stayed there, which they didn't, there wasn't anybody there, would have been, nominally 100 millirem total if they'd stayed there the entire week, which that was not the case. And we have TLD systems all around the site that we can back calculate what those were. So we have that data, and that's in the ANS Wire article that we published.
So 100 millirem, just for comparison, would be the additional radiation you might get in certain high altitude parts of Colorado for a year, or actually 85 millirem working or living in the US Capitol for a year because of the radioactive marble. So your second tour of duty, you're there, you're the, essentially the lead NRC official in charge of the cleanup. This is, after the site's been stabilized. And so I want to go into a little bit about the balance that you had to strike to, on the one hand, be expeditious in getting the site cleaned up, but also being deliberate about the actions that you took to ensure there weren't any unintended consequences of it. Can you talk a little bit about that balance and how you maintained that balance?
Yes. In the fall of '80, about a year later, is when I was asked to go and be the site director by Harold Denton and John Ahern, who was the chairman of the NRC at that time. So I went there, and the job was to be sure the public health and safety is protected and to get the cleanup done as quickly as we safely can do, because there was an unknown risk of what the core conditions were. We didn't know. We know it's severely damaged, but we didn't know if it was melted or not. We didn't know how the reactor vessel was on the base. So there was many uncertainties, and we wanted to get it into an engineered design condition as opposed to an undesigned condition that we were in. So timeliness had a risk factor to it as well. But safety was first, and to reduce the uncertainty risk was the second part of it. So this was a balance that we had to do. And as I say, it's a team, everybody in America pitched together to solve this problem. Now, the situation when I arrived there was very difficult for everyone. America, no one had ever faced the situation of, a severely damaged core, turns out partially melted core, very high radiation readings throughout the plant. We had, many R per hour, inside the containment building, and some places the auxiliary building. We had 3 meters, 9 feet of water in the containment building, highly radioactive cesium, strontium. This had to be dealt with. We'd never dealt with that type of thing before in America. Now, to deal with this, a whole team had to be created under basically GPU Nuclear took over from Metropolitan Edison, who was the original owner of it, and we had to put together basically 4 different cultures into a team. And some of this resulted in some of the procedural issues we're going to talk about in a moment. But basically, to be successful with the challenge of the cleanup of severely damaged reactor like this, first, you had to have the utility owner. That was GPU Nuclear. They owned it. They had the operators who knew the plant, who were there. We had to bring in new technologies past what operating reactor people do, because the cesium and strontium was out of the fuel. It was in the water. It was in the air in places. So we had to bring in technologies from the DOE nuclear laboratory systems, who had dealt with that in reprocessing in the defense industry. So the Hanford, the Oak Ridge, Savannah River technologies needed to be brought in. We needed to bring in substantial engineering and construction refurbishment work, like to rebuild the polar crane. So GPU hired Bechtel National to be part of that team. They're a preeminent, architect engineering company. So they were part of the team. And we had a new management structure brought in, which basically was the naval nuclear management, safety culture, conduct of operations management. So we had a lot of that management culture infused. Now, putting these 4 different cultures together into an effective team was a managerial challenge, and communications and understanding and learning was a major part of it. But this was the situation we had moving forward to do very complex tasks. For example, we had to build a whole new system to process the 9 feet of water in the basement to reduce the gamma radiation levels. The polar crane, which was on the top of the reactor building, had to be refurbished because we had to remove the 40-ton missile shields to eventually remove the head and the inner plenum to get access down into the damaged fuel. We had to do what was the quick look, was to get data on what was inside, so we could decide, was this going to have to be totally robotics, or could we put humans in there? So we did a lot of decontamination. The quick look, where we then discovered that the top 5 feet of the core had collapsed down underneath. So we learned all of these things to move forward. And part of this was the TMI team, I will say, which is GPU, Bechtel, and everything, needed to work to refurbish the polar crane. And that was one of the example of one of the major tasks we had to do, besides water and all the other tasks we had.
Mm-hmm. So complicated relationship between the partners, but a defined set of objectives. Now, in the show, there's discussion about the pressure to move fast. Did you feel that pressure?
No, I mean, expediency, prompt, safe cleanup was important. So prompt, yes, that was important because we wanted to get the core out. Okay, we wanted to get it into engineered design configuration, not an unknown configuration sitting in the bottom. We wanted to get the cesium and strontium that was in the water and air and other waste. We wanted to get those into a design for waste management controlled system in place. So we constantly were working on these with the integrated cleanup team. And what was done, GPU put together the Bechtel people in with the GPU people, and they had a unified TMI2 procedural system where they basically adapted the best procedures from each of these organizations to do specific tasks. And this is where the differences of opinion amongst individuals is to which procedures you should use for what tasks. In the case of the polar crane, evolved from this procedural differences of opinion. As it related to the polar crane, this was considered by GPU to be a major refurbishment. Now, the polar crane was a major construction refurbishment job. All the wiring had to be replaced because it was all damaged by the heat and radiation. The brakes had to be replaced. Structural integrity had to be checked very carefully. It was a 500-ton capacity crane, and it was needed to remove first the 40-ton missile shields, of which there were 4 of them over the reactor head, and then needed to be tested, and then to lift the 168-ton head itself. The head assembly had to be taken off, and then the smaller plenum had to be pulled out to get access to the core. So we knew this had to be done. And given that this was a lot of Bechtel work to do the refurbishment, they chose a procedure known as a work package. Okay, and a lot of the differences of opinion between Mr. Parks and Bechtel and GPU had to do with which type of procedure was to be used. The work packages that construction companies normally did could adapt all the quality assurance requirements, but the focus was primarily from a construction work type of thing. The utility people who were used to not doing a lot of heavy construction, but construction mods at a plant, used engineering chain notice type procedures. And they are somewhat different, but both of them will achieve the nuclear quality assurance requirements of the Nuclear Regulatory Commission. And we checked that over, and we checked the safety of it. I had, as the director, I had responsibility to sign off on every GPU operating procedure involving substantial amounts of radioactivity. I signed about 1,000 procedures a year, and I had a staff of 18 to 20 people, and we reviewed them, and we worked closely knowing technically what was going on at the plant. Now, we knew that we were moving in the February of 1983, moving toward the polar crane. We at NRC knew that GPU was using the Bechtel work package type procedures, which was okay with us because it met the engineering quality assurance requirements. If they had chosen to use the ECN type, that would have been okay too. Okay, but it was an administrative issue. Mr. Park.
So can I stop you there for a second, Lake, because I want to make sure I understand this, because it is a significant part of the show. So what you're suggesting is that what the Netflix show presents as sort of a major safety risk was actually a disagreement over what the flavor of paperwork that would be required to document the improvements needed to get the polar crane running and get the missile shields and the reactor head off. Is that a fair way of describing it?
Yes, it was. It was an issue of the procedural paperwork. When Mr. Parks didn't like the way that it was being done, he wanted to use the ECN type approach. And he basically came to us at the NRC confidentially, and we recognized his confidentiality, saying that GPU was doing this the wrong way. And we said, well, tell us what from a safety point of view was wrong. And he couldn't say that other than I don't like their procedure. And he says, I'm not sure that they did calculations like they should. So I think it was February 18th, 1983, he came to me, okay? And I said, we will look into this and see, the merits of the case. We did a surprise inspection that week at Bechtel Gaithersburg office, and the calculations were there, and they were following the procedures. The following Friday, I had a meeting with them, and we told them, I said, again, we didn't see anything from a safety point of view wrong, okay? Is there any safety issue that you have that you think is not being corrected besides the administrative procedure they're using? And he said, no. And if you look in the 57-page affidavit that he filed with the NRC later, objecting to my decision, there was no safety issue other than the procedural one. So it was administrative. There was always in the show, there was this thing about an upcoming lift. There was nothing scheduled for the next 2 months. I had not gotten the procedures yet for operations. When first procedures came to me on March 10th, I think it was, I disapproved them because they had not done the proper rigging for certifications for the slings for the lift. And then after that, Mr. Parks complained to my superiors. I told him he had the right to do it. If he didn't agree with me, he could go to the commission, and he did. And the commission asked for a investigation of it, which is fine, and they did. And then it became more of a public issue. So with that difference of opinion on the procedures, we move forward. There was testing. There was always going to be testing of the crane. The show had an impression that there was a commission meeting and a last minute thing. There was no such commission meeting that day. That's totally fictitious, what they have in the show, but it makes good television, I guess. One of the things I know, I had a meeting with Governor Thornburg. He asked, what is all this about? I explained to him what it was. And I said, we're going to be doubly sure any lifts in that containment will be done safely. And I said that I personally would be in there on the first heavy lift. So the reviews were done. The GPU made the necessary, improvements that we'd, requested to do. And the crane went forward and did successful lifts, later. So I think it was February of '84. Now took time, was the lift. I think Dan has a picture.
Dan, put up the picture of the lake, because again, you committed to the governor that you were going to be there at the time, right? So you suited up and went in.
Yeah, that was me getting ready to go in. If you notice, I have a camera there. I was, for a lot of reasons, you're just not going to stand in there and watch. So I was the photographer, for the lifting of the first heavy lifts. And the next picture, I think, is the lifting of go back one. There we go. That was the first heavy lift. This is the 40-ton missile shield that was lifted. We took the 4 40-ton reactor head shields, which you see one here, with the pressurizer shield, to give a test rig to actually do a 170-ton test lift to test and prove that the crane would be capable of lifting the head. The show has a whole lot of comments about how an accident would have caused disaster in central Pennsylvania, supercriticality, melting of the core. None of that is technically feasible. The decay heat of the core at the time in 1983 was 24 kilowatts. That's about 18 to 20 home hair dryers. Not enough heat that was going to melt anything at all. But none of that was mentioned.
Well, and let me I do want to go to one thing here, and Dan, I think you can take the screen share off. So like I want to zero in on that point. So at the time at which you were doing the reactor head lift, the energy in the core was, let's call it 18 hair dryers. Did Richard Parks know that when he made his claims? Could he have known that?
He should have known it. I mean, he wasn't a degreed engineer, but he'd been a nuclear trained, operator. So I mean, in my discussions that I had with him, now this is my memory from 40 years ago, and in all the documentation at the time, he never brought up a specific issue other than the procedures weren't being done as he thought they ought to be done. So I don't know, honestly, what he did or didn't know. We never had a technical discussion. When I asked him, what is your safety concern other than procedures? There wasn't any at that time. So what he had in the show was what he had in the show.
Right. So, but again, I think the show kind of lays out the scenario where the head drops and it damages the fuel, and the East Coast is at least some part of it is rendered uninhabitable. At least that's the suggestion of it. So moving on a little bit now to the restart of operations for Unit 1. The show, I think, touches on it a bit, but obviously there was some controversy around that locally. But was there anything in the decision to restart Unit 1 that gave you pause at the time, or gives you pause now? How do you view that decision?
Well, the 3 mile accident, in 79 and 80, everybody did the reassessment, and the whole industry changed, because we realized that this was a serious thing, and we could not continue like we were. As an industry and as a government, we were complacent, and all kinds of things we learned. So mass change came across the whole country. And so GPU, the owner of TMI 1 and TMI 2, split the organizations into Unit 1 restart and Unit 2 cleanup, and they brought in all new people, all new managers, and the Unit 1 was the restart was totally changed. So it was all new managers, Navy nuclear, captains and admirals were brought in. All the operators were retrained, new operators were brought in. It was a totally different corporation. The name had changed. The old Metropolitan Edison was gone. I mean, all the people who were really there before were pretty much gone. Certainly all the leadership was. So the NRC went through basically a 6-year process of recertifying that their operations, would be safe. Training was checked and rechecked, and all the lessons learned. IMPO, Admiral Rickover was asked to do a special review. Admiral Rickover was getting old at the time, but Admiral Rickover was still very, very knowledgeable. But he had his own group of Navy captains, which were highly trained, who went through the GPU plans with a fine-tooth comb, as did the NRC. So it was a totally different corporation, totally different people, totally different lessons learned. And I think the proof of it is it was restarted. It went on and operated very successfully for 32 years until 2019, when it went down due to the economics of cheap natural gas. Maybe now people in Pennsylvania might want to wish a little differently, but nonetheless, that's kind of what happened. But the plant worked very well. But the accident in 1979 traumatized the people of central Pennsylvania. I mean, that was the true sadness of what we, the nuclear establishment, did to the people. Now, you may have excuses. It wasn't our fault, but it was. It happened. So when TMI 1 wanted to be restarted in the early 80s, there was a lot of people in central Pennsylvania who said, never again. I mean, we were traumatized before. We were threatened. Our children were threatened. And a lot of people were very vehement about it, against it. There were also people who were very supportive of it. I think after it was running, I think people calmed down. Most did. A few people were still highly impacted by this, as you could see from the show, and still are. They were true victims of what the industry did to them, and the press did to them. And in my view, shows like the Netflix are still doing to people, of scaring them, I think, inappropriately.
Well, so I was a teenager at the time, living, I don't know, maybe 90 to 100 miles south. I can remember the eerie feeling in the days that followed, and I think one of the services that the show actually does is they go back through this rich, detailed archival footage, and they pull up the press conferences, and you realize how colossal the communications failure was in the first few days. I mean, anybody who, you can't blame anybody for being worried about it, because it just seemed as though nobody was in charge. I mean, is that, did you feel that eerie, did you feel that eeriness too? I mean, how did you perceive it? You're perceiving it from an engineering standpoint, but, when you were there on site, how did you, give me some examples of how you could sort of viscerally feel that? Your family was there, right?
Yeah, I mean, we moved there. I mean, originally when I was asked to go up there, in 1980, they said, well, you can still live in Maryland. I lived in suburban Maryland outside of Washington. And I said, no. I said, if I take this job, I have to live there in the community. I have to have a house. My children, I had 2 young children then, needed to go to local school, and I needed to see the cooling towers from my house. And they said, well, you could go do it. So I did. And I lived there, and my wife was a childbirth nurse at the Harrisburg Hospital. And so we were members in our church and knew all about how the people felt. And they were truly all good people, including the people who were on that Netflix show, the ladies, who I knew quite well. These were all really good people, but they were impacted severely psychologically by what the industry did to them. So it was real, and they would ask a lot of questions. Well, if you lived here, would you have left? And I said, well, if only news I had was what I was getting on the television, I probably would have told my wife and kids to go. But reality, there's to it. The reality, people act like they believe and what you perceive. And when you get information that says it's significant, you react that way. So it doesn't matter what reality is or isn't, it's what you believe it is. And that trauma was significant, what we did to the people of Central Pennsylvania. And never again, and I don't think it ever will be again, because we changed so much in the ability to not only do a better technical job to prevent any event like this, but also if events happen, how we communicate, accurate information gets to the press. At the time, the press touchstone was the Jane Fonda China Syndrome movie. I mean, that's what they could understand. And that was the reference case that people used. And words like the word meltdown is a very difficult word for me, I would say, as an engineer, because what is that? Is that, a molten core going to China and the area is devastated for 100 miles? Or is it what happened at TMI? Yes, some fuel melted and it flowed inside the vessel here or there, but not the consequences, minimal consequences from a biological, radiological point of view. Now the plant was ruined, of course. It's $1 billion plant was destroyed. So it was certainly a huge industrial accident, but from a public health and safety point of view, it was fairly minor.
And didn't really, I mean, ultimately, I feel like the Netflix showrunners kind of buried the lead of the story, right? There's been so much advancement in nuclear safety since 3 Mile Island and because of 3 Mile Island. And obviously they were going for sort of a certain dramatic narrative here. But, do you think they missed an opportunity to set the record straight on the safety improvements?
Oh, absolutely. I mean, there's so much that the industry did, and the government did as well, post 3 Mile Island. I mean, it was a huge wake-up call for us all. I mean, we as a nation, we were complacent about it. Those operators, were not appropriately trained to operate a B&W reactor, but they were good people. They were good operators, but they were lost that day. Okay, I mean, when they were turning off the safety injection pumps that our 1975 computer was turning on, okay, they turned it off. I mean, we never expected an operator to be a problem. We always thought whatever happened in a reactor, and from a design point of view, the operators would be there to help you and to assist you in the situation, your engineering, automation, et cetera. We never thought that they would actually turn pumps off, because they misunderstood, the instruments that they were seeing in their training. So we learned all of this, and the a key thing, I think, was the adoption of the naval nuclear management culture. The Institute of Nuclear Power Operations, the industry self-checking, they're harder on themselves than the NRC should be. And that's a good thing. So the communications, if something goes wrong, whole reporting system, even very minor items, unusual events are now reported. There's communications between the state level and the local level and the utility sites themselves. So much has changed that we learned. And I think it was an early thing that was good for America, okay, in that the backup systems did work, the containment worked. There was no, appreciable, impact, radiologically speaking, on the community. Economically speaking, in the investment side, it was pretty severe. I mean, Metropolitan Edison, GPU Nuclear, they no longer exist. Those companies no longer exist through this whole thing. So we learned a lot, and we made America stronger. We made us more protective, productive, and we made us safer. So I think we learned our lessons and we moved on. And I think the last 40 years has shown the value, and I'm hoping the next 40 years will even be better.
So I'm going to kind of dip into the Q&A here, because the questions have come in, and there's one related to this part of the conversation. So it goes like this: I watched the miniseries. How would the TMI accident be handled if it happened in 2022? How would you handle it from the NRC side if you were in charge of the event again? Or how, what procedures do NRC have in place that weren't in place then? Maybe you can give us some of the a contrast of what that would be like.
Yeah, I mean, in the post-TMI, lessons learned, both the industry and the NRC, communications and safety data are key things. All we had was a phone line, okay, to the control room, and would ask questions, and you would never, the people were busy trying to figure out what was going on. So you could not get any information. There was a whole data center. The NRC changed its incident response center completely to not just depending on a phone line or two. They'd get actually data of safety parameters. You'd get temperatures and pressures, all of that data that we just didn't have at that time. So the information flow is tremendously different. The operator training is completely different. I mean, there were very few simulators then as far as the training of the operators and the fundamentals of understanding, superheat steam and things that were fundamental that the operators really didn't understand. Thermal response, transients. So we're probably never going to get to there, okay? But if we had some event, we have the data and the flow, and they're exercised, we're training and doing responses and drills. We're in a much better situation to be able to communicate externally. The utility med ed at the time had no ability to go into a press conference. What was happening, the press people were monitoring the radio communications from the GPU monitors who were out taking samples. So they would have real-time data as to what a radiation level might be, whereas the Jack Irvine, who was the vice president, would go into a press conference. He was maybe a half hour out of date, but they would have it within a minute. And they would say, we just had a report, the level went up, or the level went down, or the level went sideways. He couldn't respond because he didn't know. And if he said something, he was then, quote, lying. So even though he was more right than he was wrong, his credibility was zero, okay? And things like we did in NRC on the hydrogen bubble situation, which happened, later on, Chairman Henry would ask a what if question. Well, what if the hydrogen was explosive, right? A simple question, but it got out of control. And so, well, NRC is doing analyses of what might happen if it explodes. And then people said, what do you mean it could explode? It couldn't explode, okay, because there was a hydrogen overpressure, no oxygen. But a simple question asked by, a very good man, and Chairman Henry was a very good man, a very good engineer and scientist, got out of control. Okay, so I think today, everybody is more sensitive. We have all learned from this. just like we've learned from Fukushima and all this. So the NRC and the industry in America, does watch its operating world much closer today. And we had not before 3 Mile Island. I mean, there's David Spessy, there's a whole lot of things we should have known, but we didn't know. So the fundamentals were changed.
So I got another question. So Lake, it goes like this. Mr. Barrett looks irritated after some questions by the Netflix interviewer. Did he know the purpose of the documentary beforehand, or did he discover the tone of the interview during the interview?
The latter. I mean, I'm a complete novice when it comes to Hollywood. Okay, I don't know anything about it. I'm kind of trusting. It was a real eye opener to me. Netflix said they want to become more of a news organization, and they wanted to know. And I said, okay, I'll talk to them. So I had several interviews with them, off camera. And none of this parks and none of this was ever mentioned. And they wanted to know about the accident and that. So we started off, I agreed to do, I checked with some other friends who they'd interviewed in Pennsylvania, and they said it was pretty straightforward. And so I trusted them. So I went and did this interview it was a 3-hour-long interview. For the first 45 minutes, it was pretty straightforward. And then all of a sudden it went into, when did you stop beating your spouse kind of questions. So I knew this was not going to be good. This was a setup. And I had a choice, fight or flight. If I walked off the set, they would say, see, the government refuses to answer the questions. Or you fight and you try to, go through it and try to say the whole story. So there was another 3 hours of what terrible things did you do? So they did a lot of editing, of course, and they would, I guess it was 2.5 hours, I was getting a little frustrated, and vented a little bit, which I should not have done. They tried to get me to say things about the ladies that were on the show. Did I know them? I said, yes, I did. I hadn't talked to them in decades, of course. And, to say something negative about them, which I would not do. These were good people. They still are good people. Traumatized, absolutely. Okay. But nonetheless, so they were trying to jazz it up. So yeah, I was ambushed. But that goes with life. Life isn't there all the time.
Right. Well, I think everyone in the nuclear professional community is grateful that you chose to fight instead of choose flight. So now I've got one back on a question related to the event itself. You may or may not know the answer to it, but I thought TMI management said to turn off the safety injection pumps shortly after 0800, not the operators. The operators kept the pumps running. Does that, do you recall that?
No, I mean, I don't think that's correct. Now, I guess I'm not sure what the person means by management. The shift supervisor and the 3 operators in the control room made those decisions. Okay, these were Navy operators. They came out of the U.S. Navy, and part of, I think, the problem was a cultural one. And let me try to explain a little bit. These folks were trained for the B&W reactor, but it wasn't the in-depth training that they really needed. But most of their experience was with a naval reactor, which is a recirculating steam generator. Okay, now a naval reactor, as the recirculating steam, has a lot of thermal inertia to it. I used to, the analysis would be like you're driving a Cadillac, you turn the wheel and it kind of turns slowly. This is a 1980s Cadillac, not a new one. But the B&W reactor is a very responsive superheat. Not a lot of volume in the steam generator, and it behaves quite differently. I sort of like a Ferrari. You turn the wheel a little bit, that thing can be in a ditch and it can go very fast. These operators were trained in something that Navy operators remember: never lose the bubble. Okay, now this was the pressurizer. You never lose the pressurizer bubble, which controls the pressure in a pressurized water reactor, which the Navy ones all are. You never lose the bubble. If you were a trainee or an operator and you lost the bubble, your career was ruined and you were laughed at by everybody in every bar for the rest of your life. So you never, ever lose the bubble. These operators, when the relief valve was open, they thought they lost the bubble. And it was like the end of the world to lose the bubble. Okay, so when the injection pumps went on, they turned them off right there. There was no vice president or senior manager or Gary Miller, who was the site manager, telling them. Now, when the George Kunder, the first, degreed engineer tech guy came in, that had passed. He asked, so many sad things happened. For example, when one of the engineers asked, is the block valve closed? The answer was, yes, the block valve is closed. What the operator didn't tell him was, I just shut it 5 minutes ago. But it opened all for the last 3 hours, right? When they basically, so they had no idea what they really did. But there was no cover up, as the thing implies at the end. People told them, well, we knew that it melted. I talked with those operators, privately after, and they were interrogated by the Rogovin, investigation, the President's Kennedy Commission, which were in-depth reviews. The show implied these were whitewashes. Those were not whitewashes at all. You can read those reports. Those were strong, independent reports, both of them. But no, there's no basis to that I know of.
Right. So another question. So how much has your experience with TMI been applicable to the work that you've been doing at Fukushima? I mean, I would assume to a certain extent it's the same. Are there any differences? How has it helped you?
Well, I mean, I guess it helps by having to understand the public situation, responding to the public and interfacing with the public in Fukushima over the water and everything else is exactly the same as 3 Mile Island. We had 9,000 tons of accident, slightly tritiated water at 3 Mile Island. We could not discharge into the Susquehanna River. Technically you could, but psychologically and social politically you could not. So it was evaporated into the environment, into the air. So we had the same dealing with the social political aspects of it as they do in Japan. The technical challenge in Japan far exceeds that of 3 Mile Island. I mean, the buildings are a shambles, 3 melted cores. The core is on the floor. It's eaten down into the concrete. Concrete through superheated steam has been, blasted away with only rebar on the pedestal. So it is technologically, it is a much bigger job to do. We have to do it robotically. We can't send people in. We could put people in 3 Mile Island, but and so that's the difference. The management challenges are almost the same. TEPCO, like Metropolitan Edison, was an operating utility. They made electricity. That's what they did. This is a cleanup job. This is like, Hanford tanks. It's a different type of business. So they have to work through getting their traditional, reactor suppliers, the Toshibas, the Hitachis, Mitsubishis, to work together into a cleanup team. So the culture of having nuclear safety culture a la naval reactors is new to them. So they are going through the same management transitions, let me say, to change to a cleanup. So that's the same. So I think there's great similarities between TMI and Fukushima, and there's completely dissimilar things as far as, certainly from a technically, Fukushima is a much greater, much bigger task. It's orders of magnitude.
So we get back, and you mentioned it again in the context of the previous question, but it's the socio-political challenges, right? Those, in many ways, there's clearly a lot of similarities where when you look at the facts, it's not as serious as how people would perceive what happened. And that's always a challenge with nuclear. If there's one thing that you could, help everyone understand about whether it's radiation or the operation of plants, like if there's one little bit of information truthful information that we could put in everyone's brain that would make it better, what would it be like?
Well, that's a hard one. I think we have to recognize, we in the nuclear industry, we have a negative stigma of the nuclear bomb. I mean, we saw it, and they had pictures constantly of that's kind of was our sad origin, okay, a weapon. Whereas we really are concentrated energy that's clean and the most concentrated form that we have to go forward. And we have to recognize that we have to work in a democracy anyway, which we are. You know, the people vote on what they believe, and that matters. You know, elections matter. So we have to, as we go through, as the country has to make choices for its energy, for clean energy, we have to address the safety and stigma issue as to how we are prepared for this. I mean, many times when I've spoken to students, university types, you know, I said, no, when cavemen discovered fire, it was a great thing on our evolution as far as the cooking meat and keeping our huts warm, but it also could burn your hut down. And it can hurt you. So you have to respect it, and you respect nuclear energy. We need to have the appropriate systems for it, but recognize that people don't necessarily see it like we do. And if you just do a pure technical thing, well, don't worry about it. That's perfectly low risk. That's it, and sort of dismiss it. We're doing a disservice, because the perception is critical. When I was younger, I used to think perception doesn't matter. Reality is all that matters. The older I get, you know, perception matters sometimes almost as much as reality. And if you look at, you know, what my grandkids will do with these internet things, okay, some of them almost live in an unrealistic world, but some people can survive a long time in virtual reality, which is kind of sad, but nonetheless, that's our society somewhat. So we need to be conscious of that going forward, and be more attentive and responsive to people's fundamental information needs as we should promote nuclear energy as a safe, clean future, as long as we don't get complacent about it, and we're not, in my view, for our future, for our great grandkids.
Well, I think, Lake, that this conversation today has made a contribution to that effort. As I mentioned in the beginning, you know, very much similar to your point, we live in an algorithm-driven world, right? Netflix chooses the content that they provide based on a level of individual information about people's viewing habits that, you know, we didn't have even 10 or 15 years ago. And so, you know, there's in many ways a greater power to scare people that want to be scared, but there's also an opportunity, thankfully, through the internet to be able to always provide that additional information out there to let people make up their own minds and really lay it out for the historical record for anybody that's interested in diving deeper in this topic. So with that, I'm going to thank you for participating today. Thank you for your service to the nuclear community over 5 decades. And we, you know, look forward to having more conversations like this with you and your colleagues down the line. But in the meantime, I want to thank everyone for joining us today. We will make a recording of this available to members later on today. And I think we will probably make this available to the public at a point at which we can get it into a form and put it on YouTube. So I would say for those that will be watching on YouTube, I'm going to do what everybody else does and say, click the link below for more information. But in the meantime, thank you, Lake. Have a good rest of the week. Thank you, everyone, for joining us, and we'll see you again soon.
Thank you, Greg.
Thank you.